at time t equals 0, the spring is in natural length. I want to find k of the block as function of time, and also I want to find the maximum k during subsequent motion of the block. So here L0 is the initial length and u is the speed of the free end. Now let us fix this as the origin x equal to 0, x equal to 0, and at any time t, let x1 be the coordinate of mass m and x2 be the coordinate of the free end. Now the elongation delta x can be written as x2 minus x1 minus L0, and this free end is always having a constant speed u. Therefore we can write dx2 by dt is equal to u always. Let us name this as equation 2. This free end has no acceleration, therefore I can also write d square x2 by dt square equal to 0, and this is my equation number 3. Now I am writing the force equation for the block. So MA, that is M times d square x1 by dt square, is equal to the force exerted by the spring on the block, that is K delta x. So delta x can now be written as this x2 minus x1 minus L0. So I brought this one from equation 1. So this is my equation 4. Then from equation 1, if I differentiate equation 1 twice, then I am getting d square by dt square delta x is equal to minus d square x1 by dt square, as the time derivative of x2 is u. If I differentiate this one again for the second time, this becomes 0 because this free end is having 0 acceleration. From 4 and 5, I can write d square delta x by dt square equal to minus k by m delta x. So I can replace this one. This d square delta x by t square is equal to minus d square x by dt square. So from 4 and 5, I can write. So here I am replacing this d square x by dt square by minus d square delta x by dt square. So I got equation number 6 now. And the general solution of equation 6, as you know, equation of this type, we can have these equations in SHM, and general solution of this equation is delta x equal to some a sin omega t plus y, where omega is root k by m. Now let us find what is the phase constant phi and what is this constant a. Now let us use some boundary conditions to get these values. At time t equals 0, the elongation is 0, delta x is 0. So if I use this boundary condition, that is I'm substituting delta x equals 0. So 0 equal to a sin at t is 0 here. So a sin phi, so I got phi equals 0. Then I'm using one more boundary condition, that delta x by delta t, then I am bringing this one from my equation 1. So you know delta x equal to x2 minus x1 minus L0. So I am taking time derivative of this equation now. So delta x by delta t equal to dx2 by dt minus dx1 dt. And then at time t equals 0, this is 0 only, because the mass m is having 0 velocity at time t equals 0. And this one, so this is the velocity of the free end, always equal to u only. So if I make these substitutions here, so here delta x by delta t at time t equals 0. So delta x, so delta x is this a sin omega t plus phi So delta x by delta t is now a omega cos omega t. At time t equals 0, so here this value is a omega, and this is equal u only, because delta x by delta t at time t equals 0 is u, because this value is 0 and this value is u. So I got u is a omega, so a is u by omega, and omega is root k by m. So if I do the substitution, I got a as root m u square by k, and then delta x comes to be, so delta x equal to, this is a here, a sin omega t, so delta x is root mu square by k sin root k by mt. So ke of block, so this is half m d by dt of x1 whole square. Again, let us find dx1 dt from the first equation, delta x equal to x2 minus x1 minus L naught, and d by dt of delta x. So this is dx2 by dt, this is u, and dx1 by dt. So here I wrote this equation here. I want to find this dx1 dt. And d by dt of delta x. So I already know the expression for delta x. So time derivative of delta x is this one only, u cos root k by m t. So because this is delta x, so time derivative of this delta x with respect time, this one, u cos root k by mt equal to u minus dx1 by dt, dx1 by dt. So from this I got dx1 by dt as u into 1 minus cos root k by mt. So k is now half m dx1 dt whole square. So this is k. So maximum value of this k is the maximum of this function. So this function has a maximum value 2, that occurs when cos root k by mt is equal to minus 1. So for this, root k by m into t equal to pi, I can find out the time at which the k of the block will be maximum.